Okay, good afternoon, everyone. Right. Okay, so for today, right? So I know like 5S and 5K, right? So they didn't learn 1.3 yet. Okay, so for 5S and 5K, right? You will learn 1.3. Okay, I will teach you 1.3 in the class. Okay, so for today we continue 1.4 first. Okay, 1.4. Then for 1.3, I will teach in the class, right? So 1.4 is actually elasticity. Okay, so in this chapter, right? So you will learn right how to describe the elasticity. Okay, and also you have to do the experiment. Okay, to investigate the relationship between the force and also the extension of the spring. Okay, and then you have to communicate about the law of related of force and extension of the spring that we call it as the Hooke's law. Okay, and 1.44 you have to solve a problem involving force F and also the extension of the spring, right? Okay, so the first one, okay, so it said to generate ideas, right? So what is actually elasticity? Okay, so we have the apparatus, spring, sponge, plasticine, and rubber band. So put in a sequence, okay, a rubber band, a spring, and also sponge, right? So what will happen? So the length will increase. So let's say if you stretch, okay, you stretch a rubber band, so the length of the rubber band will increase, right? So what happened if you remove, right? If you remove the force, okay? If you stop stretching the rubber band. So what happened to the object? So the object will return to the original shape or original length. So that is what we call as the elasticity. So elasticity is the ability, right? Ability for an object, okay, to come back, right? To come back to its original position, okay, when the external force is removed. Okay, just right now you stretching the rubber band. Okay, you stretch the rubber band, so the length is increased. But when you remove, okay, when you stop stretching the rubber band, it will come back to its original position. So means the rubber band has the ability, right, to come back to its original position. So we call that as the elasticity. Okay, so this is the example. Okay. Right. So what does it mean by elasticity? Ability of an object. So the ability of an object to come back to its original position when the external force being removed. So this is the meaning of the elasticity. So if the exam they ask you what does it mean by elasticity, so this is the meaning of the elasticity. Okay, an ability of an object to come back to its original position when the external force being removed. Okay, so this is the experiment we will do, okay, in the school, right? So diagram 3.1 and 3.2 shows a father and his son sitting on two identical bird nest wings. Okay, so the spring of the swing are extended when set by them. So what is the inference? So inference you must have the word influence or depend, right? So this one the force influence the extension of the spring or extension of the spring depend on the force. Okay, so for inference you must have the word influence or depend. Okay, so for if you use the word depend, so the extension of the spring depend on the force, okay, applied to the spring. Okay, so for the hypothesis, so the hypothesis might have the word higher or higher or higher lower. Okay, the relationship, right? So means this one, if you increase the force, okay, the extension of the spring also will be longer. So the higher the force, right? The higher the force, the longer the extension of the spring. Okay, it's like a relationship between the manipulated and also the responding variable. So here the manipulated is the force, right? and the responding variable is the extension of the spring, right? So it's like a relationship. Okay, so that is the hypothesis. Okay, so how about the aim? So the aim is to investigate the relationship between the force and the extension of the spring. So you must have the word to investigate the relationship between MV. Okay, so MV means manipulated variable, and also RV, the responding variable. Okay, because you have to remember your SPM for your Amadi, there are three types of question, right? The other, they give you the instruction, right? The other one, they will give you only like half of it. And another one, they didn't give you any instruction, but you have to do it, the instruction on your own. So you need to know how to write your inference, your hypothesis, and also how to write your aim, okay, for each experiment, right? Because last year they come out the one that already given the instruction, then they only give the result and do the graph, right? But for this year, we are not sure. So you have to know, we have to remember all the experiment, okay? But then when they give us the apparatus, the list of apparatus, we can decide which chapter will come out. Whether, let's say, last year electricity, right? So you need to remember only the electricity experiment. So that one, we need to wait for the list to come out, right? So now it's not still not come out yet, right? Okay, so you have to know, okay, how to write the report, the full report. Okay, so that one I will teach you later. Okay, when the list come out, we will see, right? So the manipulated variable is the force. Okay, the responding is the extension of the spring, and the fixed variable can be diameter of the spring. Okay, the diameter of the spring, the initial, okay, the initial length of the spring. Okay, and the uh, the type of the spring. Okay, what is the material used for the spring? Okay, that one can be the fixed variable. Okay, so this is how you set up the apparatus. Okay, so you have to know, okay, that I already told you just now, there are three types, right? There are three types of questions. So the third one that doesn't give you any instruction, you need to draw also the apparatus, how you set up the experiment, and also you need to label it, right? So this is the how you set up the experiment, okay, for the Hooke's law. Okay, actually this one is to investigate the Hooke's law. Okay, right, so this is how you do the table, record your reading, okay, and how you do the experiment. This one we do the experiment in school, so I will just skip this one. Okay, and this is the precaution, right? So remember I said to you there's only one precaution that you can use, okay? Then this one you can use for any experiment, right? There is make sure your eyes, okay? Make sure your eyes perpendicular to the scale reading, right? So this one you need to put the name of the apparatus you use. So this one use ruler, right? So the scale reading of ruler, okay, to avoid, okay, parallax error. Okay, but last year they didn't come out for precaution. Okay, only the graph and also radian, okay, and also a few questions, okay, involve the topic. Okay, but for this one, this year I'm not sure, but just remember for the experiment, they ask you for the precaution. This is only the sentence. This one can be used in any experiment. Okay, but you have to replace the apparatus. You have to see what experiment, what is the measuring instrument used in the experiment, then you replace it. Okay, for this one, you use a ruler, so you just put it the ruler here. Okay, this one you need to replace according to the experiment. Okay. Okay, so let's say we got this graph. Okay, so let's say we got this graph. Okay, after we do experiment, you got this graph. So what is the relationship here? So the graph relationship, remember only three, that is directly proportional, inversely proportional, increasing linearly, or sometimes can be decreasing linearly. Don't put the higher the force, the higher the extension. Okay, that one is wrong. That one I already told you, the higher or the higher the lower, that one is for hypothesis. Okay, so for this one is a directly proportional. Let's say they ask you what's the relationship of the graph. Remember, directly proportional, inversely proportional, increasing linearly or decreasing linearly. Right? So only four types of relationship, okay, is acceptable, okay. So don't put the higher the force, the higher the extension of the spring. That one is wrong, okay. So for this one, the graph is directly proportional. All right, okay. So it says here, calculate the gradient. Okay, so for the gradient, you must show the triangle, right? You must show the triangle, especially for Amali. Okay, for the practical, okay, exam must show the triangle. When they ask you the gradient, don't forget to draw the triangle. So how you want to draw the triangle? So of course, you know the gradient, you need 2 points, right? Okay, you need xy one y1 and x2 y2. Okay, so let's say, right, if I take 2 points, so the first one usually we take the origin. Okay, and the second one, okay, you can put it, you take it here. Okay, you can take it here. Okay, so after that, you already have 2 points. So you just draw the triangle. So it will form a triangle like this. Okay, so how about the size? Okay, the size of the triangle. Okay, for last year, right? For last year, the graph should be, the size of a graph, it should be 5 times 4. Okay, or 4 times 5. Right? So it means here 1, 2, 3, 4. Okay, or and this one should be 5. So this one is actually the example of the question. But in the exam later, we usually take until 5 readings, right? This one only 3 readings. Okay, but in exam we take 5 readings. So 5 reading you can get 5 times 4 or 4 times 5. Because this one only 3 readings, so it's not is you cannot get 5 times 4 or 4 times 5. But if we take 5 reading, yes, you can take 5 times 4 or 4 times 5. So this one is counted as 1, 2, 3, 4, 5. Okay, and this one can be 1, 2, 3, 4. So mean your graph should be like this. Okay, this is the minimum. Let's say you want it more, it become bigger. Okay, more than 5 times 4 or 4 times 5. Okay, you can use that one also. Okay, this is the minimum, right? So this is how you want to calculate the gradient. Okay, so must have the triangle. Okay. Okay, so the next part, okay, you already have your triangle now. Okay, you already have your triangle now. So what you have to do, so you just read the coordinate here. Okay, so for the coordinate, right, so this one 0, 0.03 and 3. Okay, you have to label the coordinate in the graph. Okay, you have to label the coordinate in your graph. So after you label the coordinate in the graph, okay, then you can calculate it. Yeah, using the formula y2 minus y1 divide x2 minus x1. So let's say if this one I take xy y1 and this one is x2 y2. So means 3 minus 0 divide by 0 0.03 minus 0. So I will get like 100. Okay. So then how about the unit? So for the gradient, must have unit. Okay, especially on paper, on the Amali paper, right? On your practical, okay, your practical exam must have the unit. Okay, so the unit is how you want to find the unit. So it's easy. Okay, you just need to know what is the unit for y-axis. Okay, so remember this is the symbol and this is the unit, right? Not this one is the unit. This one at the back here is the unit. Okay, and this one also the unit. So y-axis, this one you divide y divide by x, right? Y divide by x. So your unit also y divide by x. So mean n over m, or you can put n m negative 1. Okay, so remember this one, I also guide you to answer for paper 3, right? So for this one, you need to know even paper 3 or paper 2, okay, must have the unit. So how they say they come out, right? They come out in the paper 2, they ask you to find the gradient because the gradient here does have meaning, right? For the force again extension of the graph, they have the meaning. What is the mean? What does it mean by the gradient here? So they ask you to calculate the gradient. So you have to know how to calculate. Okay, how to make a triangle? You have to label, right? You have to label, and then you must have the unit, right? Okay, so here that one is a gradient. So how to find area under the graph? Okay, when x is 6 cm. Okay, so you have to notice here the unit is in meter. So if I want to change cm to meter, so I just divide by 100. So you will get 0.06, right? So means they ask you what is the area under the graph when x is 0.06 meter. Okay, so you just make a line here. Okay, make a line, right? And then after that, okay, this one is the shape of triangle, right? So you just need to use the triangle formula. So half, okay, base is 0.06, right? 0.06, and the height is 3. Okay, so you will get the answer here, 0.09 Newton meter, because this one is a multiplication, right? So n times m, so n m. Okay, so that's how you calculate area under the graph. So you must show the, right, must show the reading here, right? 0.06 is actually 3 Newton, okay, for the force. Okay, so from the graph, what is the relationship between force and the extension of the spring? So this one already we discussed just now is a directly proportional because it passed through the origin. If increasing linearly, it should be here, okay? Or if decreasing linearly, it's like this. If this one is inversely proportional. Okay, inversely proportional. Okay, what happened? Let's say, okay, what happened? Let's say your graph, okay, your line is passed through at this part. Okay, it passed through within this rectangle here, this box, right? But it's still within one box here. This one we still call it as the directly proportional. Okay, if the line of your graph, okay, if the line of your graph is within this one small box, okay, is within one small box here, okay, let's say you got like this one also we call it as a directly proportional, but it's more like more than one box, let's say here, right? So that one we call it increasing linearly. Okay, so let's say if here also increasing linearly. So if it within one box here, you can still call it as a directly proportional. Okay, so for the part of the discussion here, what does it mean by the gradient of the graph? Okay, so why we need to calculate the gradient of the graph? Because the gradient of the graph is actually equals to the spring constant. Okay, spring constant means how high, right? If they say if the spring constant is high, they say if I have this one, the spring constant is let's say 3 Newton meter, example. Okay, -1, right? And they say it's 10 Newton meter -1. So what does it mean here? 3 and 10. So you need to know the higher the value of the spring constant, okay, it means it's harder for you to stretch, right? To stretch the string, means it needs more force. Okay, so if your value of your spring constant is high, means you need more force, okay, to increase the length of the spring, to pull the spring, to stretch the spring. Okay, so means the higher the spring constant, okay, the stiffness, okay, the higher the stiffness of the spring, right? So the higher the spring constant, the higher the stiffness of the spring. Means you need more force, okay, so to stretch, right? To stretch the spring. Okay, how about area under the graph? Okay, so for area under the graph is actually equals to elastic potential energy. Okay, so area under the graph is actually equals to the elastic potential energy. Okay, so need to remind, if graph F against X, okay, the spring constant equals to the the gradient of the graph is equals to the spring constant. So the higher the spring constant, the higher the stiffness of the spring, while area under the graph is actually equals to the elastic potential energy. Okay, so I think this one you already learned when you are form 3, if I'm not mistaken, right? Okay, right. So now we move on to the Hooke's law. Okay, so what does Hooke's law say? So it says that the extension of the spring is directly proportional to the force applied on the spring provided, okay, as long the elastic limit is not exceeded. Okay, it's not exceeded. So let's say you keep increase the force, means the length of the force also we keep increase. Okay, so it's a directly proportional. As long, right, the spring, okay, if you keep giving the force to the spring, okay, it still can come back to its original position, mean it doesn't lose its elasticity. We can still use the Hooke's law. Okay, but if you keep increase the force, and then when you remove the force, and then the spring cannot go back to its original position. It has lost its elasticity, cannot use the Hooke's law anymore. Okay, it's only when the spring can come back to its original position when you remove the force. Means you didn't exceed the elastic limit. Okay, so that is the Hooke's law. Okay, right. So write an equation for Hooke's law where F is force, K is a spring constant, and X is the extension of the spring. So this is the equation for the Hooke's law, because we know F is directly proportional to X. Okay, if you keep increase force, the extension of the spring or the length of the spring here is increasing also. So means directly proportional. So if you want to write it in equation, you have to put the constant there, right? So we put the K here as the spring constant. Okay, and I already told you the spring constant is actually equals to the stiffness of the spring. So means the higher the spring constant means the stiffness, the higher the stiffness of the spring. All right, so the next part to analyze graph. So far, do you have any question? Any question you want to ask? No. Okay, so the next one, to analyze graph of x against x to determine the values of spring constant K and elastic potential energy EP. Okay, so this is the symbol of the elastic potential EP. So state the definition of the elastic potential energy. So elastic potential energy is the energy possessed by an elastic material. So any elastic material such as rubber band, alright, spring, okay. So they consist of energy. They consist energy of elastic potential energy. So energy possessed by an elastic material. So define the spring constant. Okay, what does that mean by spring constant? So force required to extend 1 unit of extension of spring. So remember I told you just now, the higher the spring constant, the higher the force that you need to increase, right? You need to increase the length of the spring. Okay, and define the elastic limit. So maximum force, okay, maximum force that can be applied so that the spring will return to its original length if the force is removed. Okay, so the maximum force, let's say like this one, right? So this is the elastic limit. So let's say if I keep increasing the force, this is just it. So I keep increase the force, then when you remove the force, you can see it cannot return back to its original position. So means you already know you already exceed the elastic limit. Okay. So elastic limit is the maximum force. So let's say the force here 10 Newton. So means 10 Newton is the elastic limit. So if let's say you increase to 11 Newton, it cannot come back to its original position. So you already know, you already exceed the elastic limit. So here the elastic limit of the spring is 10 Newton. Because when you put 11, they cannot come back to its original position. Okay, so the elastic limit is the maximum force, okay, that can be applied so that the spring will return to its original length if the force is removed. That is the meaning of the elastic limit. Okay, by referring to a graph f against x, okay, so graph f against x, so this is the graph f against x, okay, and equation f equals to kx, write an equation for elastic potential energy EP in terms of f and x, okay. So let's say if you want to find elastic potential energy for the graph f against x. Remember the graph area under the graph, right? So just now we already know if you want to use the graph, you want to find the elastic potential energy, you find area under the graph. So area under the graph is equals to elastic potential energy. Elastic potential energy. So area under the graph is equals to elastic potential energy. Alright? Okay. And you already know, always right, because this one is a directly proportional. So the shape, okay, the shape of the area always be triangle. Okay, in the form of the triangle. So we can use half f x. Okay, so half fx, right? So height multiply with the base here. Okay, so this is the formula for the elastic potential energy. If they give you, let's say they didn't give you the graph, okay, but they give you the value f and x, so you can just straight away use this formula. But let's say if they give you a graph, okay, then you need to use the graph, and of course you need to form the triangle first, then you can calculate. Okay, but for the next one, if they said in the form of K and S, they didn't give you the force, okay, but they give you the spring constant. So half Fx, right? And you already know Hooke's law is F is equals to Kx. So if I replace F with Kx, okay, then I multiply, I will get Kx square. So this is the formula, half Kx square, okay, for this one. So this is the formula if they give you the spring constant and also the extension. So means there are three ways, right? Three ways you want to find the elastic potential energy. The first one by using the graph, okay, area under the graph. Okay, if they give you a graph, you need to form the triangle first, then find the area. Okay. And the second one, if they didn't give you a graph, but they give you the force and also the extension, okay, so mean you can use half fx, okay, because we already know, okay, if we do, let's say, area under the graph from the graph, is actually a triangle. So triangle, the formula is half time base times height, right? So your base here is x, your f here is your height. So you can get half fx, okay, so that is f and x. And also, let's say they didn't give you a force, but they give you a spring constant, so you use f is equal to kx, okay, then you can derive, okay, you can get half kx squared. So you need to know what is the info that be given by the question, okay, and which one you need to use, which formula, okay. All right, so for this one, okay, they give you two type of graph, okay, spring 1 and also spring 2, right? So for spring 1, okay, you can see here, the spring 1, the gradient is more than spring 2. Okay, you can just see, right, from the graph. Okay, spring 1 is more, the gradient is is steeper, right? Steeper than the spring 2. Okay. So this one, if we can just like, if you want to compare, okay, so the gradient of the spring 1 is bigger than spring 2, means we already know this, the gradient is actually equals to what? The gradient equals to the spring constant, right? So mean the spring constant for spring 1 is bigger because the gradient is bigger compared to spring 2. So when the spring constant one, okay, the gradient is bigger, right? Means it's more stiff than spring 2. Okay. So for spring 1, the gradient is higher, okay, compared to spring 2. Okay. So means the spring constant also higher. Okay. So means the spring 1 is stiffer than spring 2. So we need more force, okay, to increase or to stretch the spring 1. Okay, that's if there's no like value being given, but you need to compare, because sometimes in the objective paper, right, they give you like A B C D, you need to analyze the graph. Okay, they didn't give you any value, but you can see from the graph its gradient is higher, means the spring constant higher, means it's more stiffer, so we need more force, okay, to increase the length of the spring. Okay, but let's say in the question, this one you can calculate, so you can use the formula to find the spring constant. So this one is actually they use K is F over X. Okay, F over X. So they apply the same force, 3 Newton. Okay, they apply the same force, 3 Newton. Okay, so 3 Newton is here. So 0.03. Okay, that one is for spring 1. And for spring 2, 3 Newton is 0.06. Okay, so means for spring 1, when you stretch it into 3, the force, you give the force 3 Newton, it will stretch 0.03 meter. But for spring 2, if you give 3 Newton, it will stretch, okay, until 0.06 meter. Okay. So here 100 Newton of force. So what does it mean by 100 Newton per meter? Means if you want to increase 1 meter, you need 100 Newton. Okay, if you want to increase the length to 1 meter, you need 100 Newton of force. Okay, and for this one, okay, if you want to increase 1 meter, you need 50 Newton, okay, to increase the length, right? So that is actually the meaning by Newton per meter. Okay, 1 meter. Okay, if you want to increase 1 meter, how many force? So this one, 100 Newton, you can increase the length until 1 meter. And this one, 50 Newton, you can increase until 1 meter, right? So this one, stiffer spring, soft spring, right? Spring 1 is more stiffer. They say there is no, there's no value given in the graph. It just gives the graph, but there is no value for x-axis and y-axis. So you can just compare, okay, by just look of the gradient of the graph. Okay, more the higher the gradient, it more stiff, mean the spring constant is higher, right? Okay, diagram below shows the graph. Okay, for this one, I want you to answer, okay, for this question. Okay, can you join the class point? Wait, I give you the link. Some of you already joined. Wait, I copy the link for you. And the code you can see in the graph. Sorry, in the screen. Wait, I send you the link. For those who don't have the link. Okay, and the code is 98043. So we got like 63. So our class should be 35 plus 16, 51. 51, 90, right? Like 24 people didn't come. Okay, never mind. Some of your friends are having a prayer, is it? Prayer. Okay, so I just start first, right? Okay, so for those already joined, you can answer this one. Okay, calculate the elastic potential energy EP. Okay, when it X is 10 cm. So you can use the graph also. Okay, but remember for your graph, you need to do a triangle. Okay, for both spring, right? You need to find the elastic potential energy for spring A and also for spring B. Before I forgot, extension of the spring means you have to minus with the initial length, right? Okay, so let's say this is the spring. Okay, I didn't put any load, okay, to the spring. So this is the initial spring. So let's say the initial spring is 10 cm. So if I put the load, okay, so it increase become, let's say, 20 cm. Okay, so for the extension of the spring, 20 minus 10. Okay, so means 10 cm. This is the extension. Okay, not taking 20 cm. Okay, extension you have to minus first with the initial length without the load. So the next question, if each spring is extended by force of 10 Newton, what is the extension of the spring? That means for spring A and spring B also. Okay, two people already answer. Okay, I will give you time until 6 minutes. Okay, then I will close. Okay. Energy. Energy is the unit is joule, right? Okay. So if you want to use joule, you have to make sure that your length, the length unit must be in meter. Okay. You have to make sure that your length must be in meter. So let's say, teacher, I don't want to use meter. I don't want to change. So you cannot use joule as the unit. Okay, so you need to put NCM. And also it's actually a meter, right? So I think you have to change your cm to meter, because newton is also F is equals to MA, right? So your A is ms negative 2. Okay, so it's still a meter. If you want to use cm, you need to change your newton also to the unit in cm. So I think it's better for you to change the cm, okay, to meter. Okay, if not, you cannot use it. Okay, 50 seconds left. Okay. No one still want to submit the answer? Okay, never mind. All right. 1, 2, 3. Okay, so let's check the answer. Okay, calculate the elastic potential energy EP when X is equals to 10 cm. Okay, so again, what you have to do here, okay, okay, the elastic potential EP when X is equals to 10 cm. So when your X is equals to 10 cm, your force is 10 Newton, right? So that is, okay. So the first one, this one they use the formula half is equals to kx squared. Okay, half is equals to kx squared. Okay, so you need to find your k first. Okay, you need to find your k first. Okay, so your k is f over x, right? This from the formula, f is equals to kx. So your k is f over x. Okay, but you can also find directly, okay, from the area under the graph, right? So k is equals to f over x. All right. So your f here is 30. Okay, for the spring A, right? So for spring A, okay, for the spring A, so is 30 divided by 0.5 cm. Okay, this one they change it to the meter already. So you will get 200 Newton per meter. And this one, if KB means the spring constant for B, K over X, 10 divided by 0.1, you will get 100 Newton per meter. So this is your value for K. Okay, and then you can use, okay, the formula half kx square. So for spring A, the spring constant is 200. Okay, and the extension of the spring, okay, they give you x is equals to 10 cm, right? So means your extension of the spring is 0.1. You need to change it to meter. So you will get the answer 1 joule. Okay. And for this one, right, for spring B, okay, half is equals to kx. So your k is 100, okay, and your x is, because they want to find when the extension is 10 cm, so you just replace x with 0.1, you will get 0.5 joule. Okay, 0.5 joule. Okay, so the next part is if the spring is extended by a force of 10 Newton. Okay, by the force of 10 Newton, so F equals to Kx, so your X is equals to F over K, right? S over K. So your force now is 10 Newton. So you already have your K value here. Okay, there is 200. Okay, you just divide. You will get 0.05 meter and you change it to cm, 5 cm. Okay, for the the extension spring for B, okay, so F is divided with K. So your F is 10 Newton. Okay, they said they apply 10 Newton. Okay, and your x is 0. Sorry, this one your k is 100 Newton, right? Your k is 100 Newton, so you divide, you will get 0.1 meter. So 10 cm. So this is the extension of the spring when you put the force 10 Newton on the object. Okay. So let's say if you want to find area under the graph, okay, can we get the same answer? Right? So let's say if I put, I want to find elastic potential EP, because they give you a graph, right? You can just straight away use the graph. So let's say I want to find for spring A. So the extension is X is 10, right? So means here. Okay. So half times, so your F is 20, your X is 0.01, 0.1, sorry. Fx. So 20 times 0.1, right? So you will get time 10 times 0.1. You will get 1 joule. Okay, same, right? Or you can, for spring B also, you can find, right, area under the graph. Let's say it's 10 Newton, right? Sorry, 10 cm. So here, right? Okay, for spring B, here. So half times your F is now 10, right? 10. Your length is 0.1. Your extension is 0.1. So 5 times 0.1, you will get 0.5 joule. See, the answer is the same. Okay, you can use the area under the graph also. Okay, either you want to find the value of K, then after that you want to replace it. So it's like quite a lot, a long calculation. Okay, so you can just straight away use the graph. If they give you a graph, if they didn't give you a graph, then you need to find this one like this. Find the K, okay, and find, then you can replace, okay, in the formula. Okay, and if each spring is extended by force of 10 Newton, okay, what is the extension of the spring? 10 Newton. 10 Newton is, for this one cannot, you have to use the formula, right? If the each spring is extended by the force of 10 Newton, so the length here, yeah, you can just straight away find, right? This one, 10 Newton, the extension is 10 cm. This one, 10 Newton, the extension is 5 cm for spring A. Okay, can just straight away get from the graph, right? So let's check your answer. So it just compare. So this one is stiffer spring. Okay, you can just see from the gradient here. The spring A gradient is higher, so mean is more stiffer. Okay, so the spring A is suitable to extend the small and with small energy. 0.5 joule. Correct. $50 Newton. No. 0.4. No. You use F is equals to 10. Oh. Alex, are you okay?
Yeah.
Did you understand?
Now I understand.
Oh, okay. How you get until 21, 27? Caroline? Wait, okay. Do you have any question to ask? Okay, so means because they give you a graph, you can straight away use a graph, or you can use the calculation, find the k, and then use the half k at square. Okay, but if they say they give you a graph, just straight away use the graph. Okay, it's a lot easier, right? Okay, so we move. They have still have 7 minutes. So to discuss the factor that affect the value of the spring constant. Okay, so there are four factors. Okay, there are four factors that affect the value of the spring constant. What does it mean by spring constant? Means the stiffness of the spring. Okay, so there are four factors. So the first one is the length. Okay, the shorter and the longer. The diameter. Okay, the diameter of the spring. Okay, and the thickness of the spring wire. Okay, sometimes they use a diameter of spring wire. It's different from the diameter of the spring. Diameter of the spring, they say this is your spring, right? This is diameter. Okay, but let's say if they've said diameter of spring wire means the thickness of your spring wire, because your spring, yeah, this is the thickness. Okay, the thickness of the spring wire. Okay, so you need to differentiate. Sometimes they didn't put thickness, they put diameter of spring wire, mean the thickness of the spring wire. If they put diameter of the spring, so let's say this is your spring and this is the diameter. Okay, and the type of spring, it means it made from what material. So whether it's steel or copper. Alright, so this is the experiment. Alright, so the length of the spring. So shorter spring, okay, we have the higher spring constant, means it's more stiffer. Okay, shorter spring has higher spring constant, means it's more stiffer. Okay, long spring have the lower spring constant, means it's less stiffer. So it's more elastic. So means it's easy for you to stretch it. Okay, compared to the shorter wire. So you just need to remember shorter wire, high spring constant, more stiffer. Right? So this is actually the comparison. Right? So let's discuss this one. So the diameter of the spring, okay, the smaller diameter, right? The diameter of the spring means this one. Okay, and this one. So you can see the diameter. So the smaller diameter, it has the higher spring constant, mean it's more stiffer. So this one is more stiffer. Okay, it's stiffer. Okay, and the thickness of the spring means the diameter of the spring wire. Okay, of course, if it's thicker, it will be high spring constant, and then it will be more stiffer. It's hard for you to stretch it. Okay, and the type of spring material. Okay, so usually steel. Okay, steel has the high spring constant. Okay, it means it's more stiffer. Okay, it means it's more stiffer. More stiffer means less elastic. Okay, so there are then another one. Okay, diameter, thickness. Okay, type, and another one is length, right? Okay, Means the shorter spring. Okay, I just add this one here. Shorter spring has higher spring constant. So it more stiff. Okay, so there are four factors. Okay, they say if I only take the if I want my spring, okay, to be more stiffer, okay, to be more stiffer. So the first one, the length should be short, okay, short spring, okay, and smaller diameter of spring, okay, and the higher diameter of spring wire. Okay, that means the thickness of the spring should be higher, and also the type of the spring should be steel. Okay, so let's say if I want my spring to be more stiffer, four factors. Okay, so mean I need to choose shorter wire. Okay, smaller diameter of spring. Thickness of the spring is higher. Okay, thicker wire or high diameter of spring wire. And another one, the type of the spring, okay, it must be made by the steel spring. Okay, so there are four factors. If I want my spring to become more stiffer, you need to know, okay, what is usually the you want. Whether you want it to be less stiffer, then you choose the opposite one. Okay, the opposite factor. So I just discuss this one. I want more, it become more stiff. So I choose small diameter of spring, high thickness or thicker wire, or high diameter of spring wire. Okay, and also the type must be steel spring, and another one shorter spring. Okay, this one is will help you in the modification. Remember the essay part, section C, right? Section C, that one that you cannot choose, you have to modify. Okay, let's say they give you, you want to find, you have to modify the absorber for the car, right? So usually for the absorber for the car, you need a stiffer spring. So you need to consider that four factors. Okay, this one I already discussed just now. Okay, I will give you the notes, okay, on Monday. Okay. All right. So I think I will stop now. Okay, we will continue this one on the next class, right? On the next class next week. Okay. So thank you class, right? So take care everyone. All right. Bye.
My teacher.
Bye.
Thank you.
Thank
Thank
you,
you.
Chair.
Welcome.
Thank you,
Welcome.
teacher.
Welcome. Thank you. Welcome.